Awesome. Okay, welcome to the second recording, part two of the week 8 Intro to C++. I'm just in the week 8 folder here, and I'm just covering what we're going to do this week. We just did the survey, the faculty feedback survey, so appreciate you guys doing that and taking the time. If you haven't, then please check your email and check the link and the announcements for where to find that. Awesome. So we've covered our midterm, and now we're going to look actually today at how to make a function declaration. So I'm just wanting to ask you guys a couple questions before we do this. In Java and your experience so far programming, how much experience do you guys have creating functions? Do you guys understand how they work, how they can return different types of variables, how you can pass parameters, how you can pass parameters of specific types? Or do you guys not really know? Have you guys not really used functions yet? Just curious, want to get to know a little bit about where you guys are starting from. Return void. Yeah, so if you do a void, then yeah, it returns nothing. Yeah, with no return type. So that's this third example over here, Simon. You got it? So we're going to be looking at functions a little bit today, and then if we get past that, then we're going to look at enums and structures. So I'm going to open up, you can download the slides from here, chapter 7 slides. I have them downloaded already, so I won't download them from Blackboard, but here we go. So you guys have some experience with how to code functions? It's kind of what we're looking at here today. So let me, cool. How to code functions. So I'm going to kind of switch between this and live coding when it makes sense, but here's our objectives for today. I won't read those all out, but we're going to understand, how to make a function, basically how to call a function, how to use reference parameters, and then, yeah. So let's get into it. The syntax for defining a function. So you have your return type first, right here. So this is the return type. Then you have the function name. So you can call this whatever you want. And then if you're passing parameters or variables to it, you put them in round brackets. You can pass an array as well. But remember, an array is just an address in memory in C++. So you're just going to be passing the address in memory. So it's not making a copy of the array. It's actually going to be changing the array if you pass the array. And then inside the function, we can do whatever logic we want. So if we want to loop or have an if statement or something like that, it's all inside these curly braces. We can also have a function that doesn't return any data or accept any arguments, and it kind of looks like this. So it's a void because it doesn't return anything. If it were returning an int, you would do int, but because it returns nothing, we just say void. And then we called this function display title, and then inside of the function, inside the curly braces, notice there's no parameters being passed here in these round brackets. So there's nothing we have to pass. When we call display title, you literally just call it like this with the round brackets, but we're not passing any items in the round brackets. And then all we do inside of the function is we print out miles per gallon, end line, end line. Okay, and then when you call it in your code, you just call display title, and then it will run whatever code is inside those curly braces. We can also make a function that accepts an argument but doesn't return data, so it's still a void up here. We still are returning no data, but we're passing it data. So when we call it display title, it's going to expect something to be passed into the round brackets this time. So because we have said, hey, you should expect a string called title that you're going to later print out in your cout statement, when we call it, we have to pass it a string called title. So here we've got a string called title, and in it, I've called that title miles per gallon calculator. And then when you call the function display title, then we actually pass it that title string. All right, and then this way, inside the function, we don't have to actually know what the string is. We're just going to use whatever's been passed to us from whoever's calling the function. So a little bit of a visualization before I get too much into it here. We've got 3 examples here. The one we first looked at was number 3. So it's a void, which means it returns nothing. So here we've got a return statement, and you can see it says optional because it's not actually returning 0. It's not returning anything. It's returning nothing. It's a void. So we don't even have to write return if we want. And then the function name, obviously, every function has to have a name. And then inside these brackets, there's no parameters. That's why the 2 is pointing there, and it's parameters, but we don't have any parameters in this. So then any statements you have, if statements, for loops, and then the function's done. So if we look at CodeLight, we can see we always have, remember, we have a main function. So the main function is a function. We've worked with functions this whole time. You know what functions are. We just haven't made our own custom functions. So the main function actually is a type int. It returns an int. So everything that happens in our program happens in the main function, and then it returns a 0, which is an int. And that 0 represents that no errors occurred in our main function. So if this was a void main, right? Now, it has to be an int just because the way C++ works. If it was a void main, we wouldn't have to return anything, but it's actually int. So just wanted you guys to be aware of that. Cool. The next example we looked at here on Blackboard was if we're passing an actual parameter here. So this one we're passing an int, and then inside of the statements we can reference the int a that was passed into it, and we can do any math or logic statements that we want to in there before we return 0 because it's an int function that returns an int. And then this last one is a function that returns an int but no parameters, and then it still returns 0 because it's expected to return an int. And then basically when you call that function, you're going to get something back, and you're going to get either a 0 or a 1 or a 2 or a type of int that you can do something with your logic, right? So you could have a function that expects to return a string, and in the function it asks the user to enter something in the console, and when you call that function, because it's going to return the string to you after you call it, you can save it in a variable. And I'll show you a little bit later what I mean by that. Okay. So we can also pass more than one argument, and all you have to do is just add a comma after. So here we've passed a double miles and double gallons. So we've got a function called calculate miles per gallon, and in it we're passing 2 variables, and they're both doubles. And inside of the function, we do a little bit of math. So we make a new double called MPG, and we take the miles divided by the gallons. And then we do MPG equals, and we use something from the C math library where we round it, times it by 10, and then divide it by 10. So we can get a float or a double, actually, for what our miles per gallon is. And then we return the MPG variable as a type of double. So when it's actually called, look at this. This is what I was kind of talking about. So here we've made a variable called 500, and we've made a variable called gallons used of 14. And then when we pass those 500 and 14 to the function, it's going to go up into here and actually do the math with those numbers, 500 divided by 14, round it, get 35.7, and then it's going to return 35.7 MPG here. It's going to return it, and see how they've actually made a double MPG equal to the function? Because this function returns a double, it's going to save that number in this double MPG. And we can actually call the variables the same name. Those are 2 separate variables. They're just in different scopes, right? So this scope might be in our main function, and then this scope is actually in our function called calculate MPG. So we could have these called something else. This could be MPG1, MPG2. It doesn't matter. They're not going to overwrite each other. They're actually 2 separate variables, and we're just able to use the same name because they're in different scopes. Any questions about that so far, or does that make sense? I know it can be a little bit wordy and a little bit confusing as we get into some of the function stuff. It can get pretty hairy pretty quick. No questions so far. That's good. So this is kind of what the console would look like, and all behind the scenes, it's basically going to that function, doing the math and returning it back, and then printing it out. So here's the code for that program, which will actually, we'll run that right now. I'll show you guys in CodeLight what that looks like. So here we are in CodeLight. If you want that code, I can post it on Blackboard or something, but we've included the IOStream and the CMath libraries in our header, and then we're using the standard namespace. So we've got a couple of functions here before our int main, right? Does function in C++ have private or public or protected? That's a good question, actually. You can do private functions. I don't know. Public, yeah, it looks like you can. Protected, I don't know. Yeah, it looks like it's the same keyword. But I haven't actually gotten there yet, Simon, so you're a little bit ahead of me. But yes, it looks like you can use those. I'm just kind of covering the basics in this stuff. But yeah, if you wanted to have like a private function in a separate class that only that class can access, then yes. But we haven't even talked about classes yet because we're going to get to object-oriented programming with C++. But yes. Does anyone know, this is kind of a fun question to test. Don't Google this, just see if you know it. Does anyone know the difference between an object and a class? What's the difference between an object and a class? We'll get to that when we cover object-oriented programming, but I just thought I'd ask to see what you guys think. The difference between an object and a class. Just think about that. Okay, so going back here. So we've got our int main, right? And that's everything inside of this curly bracket to this curly bracket. Okay, so all of this. But above it, we can see we've got two functions. So from lines 10 to 14, I've got this double called calculate MPG. So the double means it's going to return a variable of type double. And we can see it returns a variable called MPG. And on line 11, I defined MPG as a type of double. And it takes miles and divides them by gallons. Okay, so that's what the calculate MPG does. And it actually takes two parameters. So when we call the calculate MPG function, it's expecting to get two parameters of type double, and the first one will be called miles. The first one will be saved in a variable called miles, and the second one will be saved in a variable called gallons. And then we can do whatever we want with those two variables inside of our function. Right? I could call this 1, and I could call this 2. Well, maybe not 1. That's a terrible name. I could call this Ben, and I could call this Mark, and then we could do Ben divided by Mark, right? And then that would actually work. If I save it, this is now the variable that I'm saving whatever is input into my function, right? So when I actually call this function and I pass it miles from line 20, it's now going to be put into a variable called Ben inside of the lines 10 to 14, and then I do Ben divided by Mark. Now that's obviously terrible naming convention, but I know sometimes it can get confusing. Sometimes people think that this miles variable from line 28 is the same variable as line 11, but they're actually different. It's all about scope. So this is the miles variable within the main scope, and it lives within lines 16 to 34. And then this is the miles variable within the calculate NPG scope, which lives within the lines of 10 to 14, right? So we can call these whatever we want. And then the other function I have is a void. So it returns nothing and also takes nothing. It's just called display title, and all it does is see out mile per gallon calculator, right? So then we can see, starting in our int main, where our main program lives, we call the display title function with empty brackets because it expects nothing, right? There's no parameters that it expects. And what this will do, if we run this, is it'll basically call that function and then run the code from line 6 to 8 as if they were sitting here on line 17. So what this will do is it'll display that title on our console. And then what we're going to do is we're going to ask the user, how many miles have you driven? Save it into a variable called miles. Ask them how many gallons of gas they used. Save it into a variable called gallons. And then we're going to call our calculate MPG function way up on line 11. and pass it those two variables that the user just entered and save it in a double right here. So there's a lot happening on line 28. Basically, all the code from lines 11 to 14 are going to be run as if they were right here. And then whatever that magic number it returns on line 13 will be saved into this variable on line 28. And then we just output it to the console. So let's run this and let's see what it looks like. Okay, so we can see display title got called on line 17 and it displayed that title right away, miles per gallon calculator. And then we see that line 21, C out, enter miles driven has been called. So now I'm supposed to enter a number. So let's say I drove 650 miles on one tank of gas. Okay, and now it's asking me from line 25, enter the gallons of gas used. So typical gas tank, I don't know, 65 liters or 60 liters. It's going to now run the math from the calculate underscore MPG function. And on line 28, this is what's going to get called next because it's going to save what I just typed into this variable. It's going to pass 650 and 60 to the code up here between lines 10 to 14. And it's going to divide them by each other, times them by 10, divide by 10. And then it's going to return it, save it in this variable, and then print it back out to me on line 30. So I hit enter. All of that happens. It prints it back out to me. Miles per gallon is 10.8, right? And then we hit the end of our program. Any questions about that? Does that make sense? Is it confusing to anyone? Do I need to walk through it a little bit slower, or is it pretty straightforward for you guys? I know you guys, some of you, when you've submitted your work in the past, have submitted stuff with functions in it already, and we haven't covered it yet. So I just want to make sure everyone's on the same page and that we're not going to go too fast and skip over something where someone's going to get lost. So let me know if you want me to go over it again. I can. If it's pretty straightforward, because you guys all have experience with functions, then I
Yes,
can move a little bit.
Professor, if you could show why we need this line with round. If we will comment this round, it will be different answer or no?
If I can show the line, which line?
Show the function, please. I don't remember number of line. I think
Oh,
it's line 12. I think it's line 12.
Line 12?
Yes, if you will comment this line.
Oh, if I comment this out?
Yeah.
This is just kind of, oops, I'm in the French keyboard. I think this is just really, we're using the round function. It's just formatting it so it looks nicer. So I can save this. Let me end the program. And then it's just formatting it, right? Because then I'm going to get 65 divided by 60, and it'll probably print out a lot more zeros than I actually want. So 650 divided by 60, and we get 10.833333. So what we're doing is we're just rounding it up. So what did I actually get? 10.8333. If I uncomment this now, that round function is just going to do 10.8, I believe. 650. Yeah. So we just round up, format it.
I think if I understand correct, if inside function we have two MPG, return will be last one.
Sorry, say that again. So if I do
line
what?
13, return MPG from line 12.
Oh, yes, you can. Yeah, you've got it totally. So what you could do is you could take, instead of setting this variable to this code, what you could do is just take this here, and then, is that what you're saying? And then comment that out. Something like that?
Yes. So we could do
Yeah,
this way
so that
too.
should work. The only thing is here now, well, and it wouldn't really make a difference if something doesn't work, like if there's a 0 in there. Let's just take a little look at this and see. So I'll exit the program again. So we're basically just saving a step. This could look a little confusing for, someone running your program, but let's see. Enter the miles driven, 650, 60. There we go. Yeah, exactly. It works perfectly. So yeah, you can just take that extra little step out if you want. It does look a little bit maybe messier, I guess, but you're doing it all on one line. So you could even do, instead of setting this to MPG, you could put miles divided by gallons, kind of like the same thing up here inside of brackets like that, right? If you really wanted to. And then you don't have to ever make this. The only thing is now it's not necessarily set to a double, right? Because here I'm actually explicitly setting it to a double. Here I'm just assuming that whatever math happens, it's going to assume that it's a double. But if it's, say, 600 divided by 60 and it equals 10, and maybe the compiler interprets it as an int, we might get an error. So here, if I explicitly set it as a double, then that's maybe a bit better. So we can try this and see what happens. So let's do 600 divided by 60. Yeah, that's fine. And it might already know that it's a double because up here I tell it it's returning a double. Like, the compilers are pretty smart nowadays, but this might not be the best practice to do all of your logic in the return statement, if you know what I mean, right? So sometimes it's a little bit more straightforward if you just do all your logic and then you just return the variable. As a developer reading this, it's a lot easier for me to interpret that than to interpret all of that in one line in the return statement. But yeah, good job, Mila. Anything else that you guys want me to cover before we move on? Oh, I saw someone's mic was unmuted there for a sec. No? Okay. All right, so I'm assuming that functions are making sense. Oh, hello? Oh, I thought I thought I heard someone. I'm assuming functions are making sense to you. That's good. Okay, so looking at the syntax for declaring a function. So what we can do is we can actually, there's something called declaring a function and then defining a function. So declaring a function is something you can do at the top of your C++ program so that your compiler knows when it's going through the code what to expect for that function. It's not a necessity that you do this, but it can be something that helps out later on if your code is really, really long or you have a bunch of functions named a similar thing. Excuse me. Like here we've got a display title function and then we overloaded it. That's the term, overloading, when you use a function that has the same name, but you're passing it different parameters. So you might have a function called display title that has, a specific title for the program. Then you might have a function that's called display title, but it returns something instead. So we've overloaded this function and we're declaring, how these functions work, what they expect, what parameters should be passed, and how they should act when they are called, and what they should return to the user. So here we can see at the top of the program, you've declared two functions, one called display title and one called calculate MPG. Now, these are not actually the functions defined themselves. These are just declared so that the compiler knows what to expect. Like I said, you don't have to do it. I didn't do it here, right? I didn't declare them here. These are just the functions themselves. They're not actually declared, but if you do have them declared, it is typically best practice. So you can see here we called function 1, we called function 2, and then here we can see we've actually defined the functions. So defining the function means that you're actually creating the logic for the function, and that's the actual function itself, right? I think you guys probably understand this, but I'll cover it quickly. Functions that use local variables versus global variables and what's best practice. So everything that we have in here that I've being passed into the function, so amount and tax rate, are local variables. We're saving it to a variable called tax. And this variable called tax, this double, is only accessible inside of these these braces, curly braces. I can't access that outside of that scope. And what I mean by scope is outside of those brackets. I can't access that variable. It won't know what it is. It won't even understand that it exists, right? So a little quick example of that. If I made an int in here and called it fave number equal to 111, okay? And then later down here, let's try say I try to see out fave number like this, because this is declared inside of this scope, lines 10 to 15, if I save this, we can see we've got an error here. And if I just make my output view a little bit bigger, if I try to run this, it's going to say fave number was not declared in this scope. So inside of int main, there's nothing called fave number. If I double click this, yeah, it highlights the thing that has the same words, like the compiler knows that they have the same spelling and the same formatting, but it actually can't see inside of that function because this is where this was declared. So that's a local variable. Okay, so that's what that is talking about. Now, if I made a global variable way up here outside of this function, outside of this function, and outside of this function, so let's say I made a global variable called, favenum global, and I set it to be 111. Now I can access that anywhere throughout my entire program because it's at the very, very top. Just like I can use anything from CMath or IOStream or the standard namespace, because this is outside of all of these functions, we'll be able to see this if I go like this, see out, favenum global, and if I do it here as well, see out, favenum global, and then say we do it here as well, see out, favenum global. It's able to see it everywhere, right? Because it's at the very top, it's outside of those scopes. So that's why we call it a global variable. I'm going to undo that because that's actually not best practice. And I'll show you. It's not recommended. So you can have a variable outside of the function and use it in both, but it can get changed anywhere at any time, and you don't know what's changed it, and it's not best practice, and that's why. A local variable that shadows a global variable is also not recommended. So here we've got a global variable called tax, and then inside of this function, we have another variable called tax, and then we set it to display the local stuff, and then back in here, we display the global stuff. It can kind of get confusing. So you should use separate names if you're going to use similar items, or at least call it like local tax or local variable tax, global variable tax, if you're going to be doing something like that. Now, something that is okay is to use a global constant. That's because constants don't change, right? So if you want to have access to how many months there are in a year, or a user's favorite number or something like that that will never change, then you make it a constant and you can define it at the very top level, highest level of the program so that everything can see it because it's something that will never change. And then, if it's going to be used for math, or if you have a constant like pi and you're going to be using it for calculations for the area of a circle, then it's good to have those accessible all over the program. So that is okay. And here's kind of a hierarchy for, a program. Well, I can show you the program after this. We won't get too much into it, but your main function kind of sits on top and it will call all of the functions from inside of it, right? The main function is the main thing that runs your program. And if you have other functions, they kind of will look like this, nested inside of it, because this main function will call the display menu and then the convert temp. And then the convert temp function actually has two functions nested inside of it that it calls, and it can call convert temp to Celsius or convert temp to Fahrenheit. So if we kind of look at a bit of the code here, let's see. We can see inside of our main function, we call the display menu. So that's why that was nested inside of the main function. And then inside of the display menu, we call the convert temp function. And then inside of the convert temp function, we can see they've either called to Celsius or to Fahrenheit in the next case, switch case statement. And that's why that's nested inside of the convert temp function. see, what else was I going to show you? Another interesting thing with functions, we can set default values. So we can, when we declare them, we can set a default value here for the yearly interest rate of 3, and then the default value for the years of 10. So when you actually declare them inside of the parameters right here, you can actually set a value that's going to be default used. If nothing's passed to it, then it will use those values instead. If you want to call a function with default values, you can either call it and only pass 1 argument, 2 arguments, or 3 arguments. And if you pass all 3, then it will obviously replace those default values. But if you don't pass all 3, then it will just use whatever default value was set originally when the function was made. Cool. Let's see, what else? Okay, so talking about overloading, I kind of mentioned it earlier before. So here we have an overloaded function in the 2 Celsius. So this is part 1. So for double values, if we're going to pass a double to the 2 Celsius, 2_Celsius function, we're going to be expecting a double and saving it in a variable called Fahrenheit. And then we're going to do a bunch of math with doubles. But then we also can overload it by using the exact same function name, 2_Celsius, but now we are expecting a different return type. So now it's expecting an int, not a double. So that's called overloading. So you use the same name, but you change something about either the return type or the parameters that are passed to it, and you use them depending on what you want or what you want to do with your program. So if I was a user and I just entered, 13, then automatically the compiler knows, oh, he's passing an int because 13 is an integer, it's a whole number. So we're going to use the int version of the 2 Celsius method or function. But if I pass 13.4, because that's a double and it has a decimal place, then the compiler automatically will use this double version of the 2 Celsius. So you can kind of think of overloaded functions as multiple versions with slight alterations to the same function. And then obviously you'd probably want to do the same type of math, but you can put whatever logic you want inside of them. But you want to do the same type of math, and then it's just going to do the same type of math with a different type of variable or number. Cool. Here's another version of an overloaded 2_Celsius function. But this time it's a double, so it's still returning a double, but they're actually expecting 2 parameters or 2 arguments being passed into it. So here they're getting a double Fahrenheit as well as the int of decimal places. So we can see here they save what's passed into it, the Fahrenheit double, and they call the 2 Celsius function again. They save that in a Celsius variable. Then they run through if it's greater than 0, and then they loop through the decimal places. So basically, if you wanted to pass a double, but then you also wanted to say how many decimal places you wanted it to go to, then that's another version of this function. It's a little bit more complicated, but then they're looking at the number of decimal places the user passes in, looping through in a for loop, and adding a 0 for each time they wanted to loop through those decimal places. And then they're just going to round it up and make it look nice and pretty. To call an overloaded function, okay, so that's how you make an overloaded function, but to call an overloaded function, it just depends on what you actually pass to it. So with our 2 Celsius function, we had one that expects 1 parameter, one that expects a parameter and then an int, or a double and an int, and then one that expects just an int, right? And those were the ones that we just looked at. So if I said like I passed the number 13, which is a whole number or an int, here they're passing 120, which is an int. And then they call the 2 Celsius function, but because they're passing in an int, it's going to actually call the overloaded function that returns the type int, which was right here, this one. All right, but if they pass 2 parameters to it, they pass a double and an int, then it's going to call this one that we just looked at on slide 28, the more complicated one. It automatically knows which version to pick based on the parameters and variable types passed. And then if you just pass a double, 120.0, then it's going to call the double version of that function. Okay, we're going to talk about reference variables, and I know who was it that kind of was talking about pointers. We're going to talk about reference variables first. We're going to take a little bit of a break here, though. We'll take a 10-minute break. We'll come back at 12:27-ish. It's 12:17 right now. I'll pause the recording, and then we're going to talk about reference variables and how those work. So I'll stop the recording here.